Hello everyone. So in this video we're going to talk about the hypothesis test procedure. So please review the canvas before you watch this video about the 5-step procedure, and also you need to understand the population and the sample, and also a hypothesis test is an inference procedure. So you need to understand what the inference is. Inference is basically about how do we draw conclusions toward the population of interest. Okay. So now let's look at the example here. So we're going to do some manual work here. Later on in the next video, we're going to talk about how do we do the hypothesis test using the Excel. And you can see basically using the Excel, all it does is do the calculation part for you. You still have to understand the 5-step procedure for the hypothesis test in order to understand the output from the Excel. All right, so here let's look at the example. A researcher wants to see if the average lead content in the lake is higher than 15 ppm parts per million. He randomly selected 10 spots on the lake surface and obtained a glass of water from each spot. The glass water are sent to a lab to measure the lead content, and it shows the average lead content of the 10 glasses of water is 18.4 ppm, with a standard deviation of 5.8 ppm. If we know that the population standard deviation of the lead content of all the spots of the lake is 6.0 ppm, perform hypothesis test to analyze the data. So there are a lot of things we need to talk about in this video. So first, you need to understand what is the sample and what is the population of the study. Okay. So population will be the entire group of individuals that the researcher is interested in. And the sample will be the group of individuals that the researcher actually obtained the data from. So in this example, where did the researcher collect data from? That will be the 10 spots randomly selected from the lake. That's the sample, right? And the population will be what? Population will be the entire lake. Right? So our interest is the population, but it's not possible to measure every single spot from the population. So we only measure 10 spots as a sample. Okay. So we need to know something about the population. That means we need to do a hypothesis test. We need to do an inference. Here will be hypothesis test. So now let's see what information are given to us. We have a lot of numbers given to us. So first, we have 15 ppm. Then we have 10 spots. And then we have 18.4 ppm. We have 5.8 ppm. Then we have 6.0 ppm. So we need to know what each of the number represent and what are they. Okay. So basically, are they parameters or statistic? And if they're parameters, which parameter is it? If they're statistic, which statistic is it? So here we've mostly focused on parameters of mu, sigma, and big N. So basically population mean, population standard deviation, and population size. So basically number of individuals in the population. Sometimes population size could be infinity. For example, in this case, how many spots are there in the lake? A lot, right? It could be infinity. And then versus sample statistic, X bar, S, and a small n. So this is sample mean, sample standard deviation, and the sample size. Okay. So when we look at all the numbers, 15 ppm Which one is it? Is it describing the population or is it describing the sample? So we want to see, basically here, we want to see if the average lead content in the lake for the entire lake is higher than 15, right? So this is something describing in the entire lake. So this will be a population parameter. Then which one is it? Is it the mean, or standard deviation? Definitely it's average, right? Average is mean. So this is population mean. Okay. Then 10 spots. That's kind of easy, right? That's the sample. If you're able to answer the sample, then the 10 spots will be the sample size n, small n, right? And 18.4. Okay. So 18.4 is describing what? Is it describing the 10 spots or the entire lake? Basically, it's describing the sample or population. We can see that 18.4 is the average lead content of the 10 glass of water, right? That'll be describing the 10 spots. So that's a sample statistic. Since it's a average, that means it's X bar, sample mean. Okay. Then 5.8. That's also describing the 10 glasses of water. There's also a sample statistic. And which one is it? It's a standard deviation, so it's sample standard deviation S, right? And then what's 6.0? So this will be the population standard deviation of lead content of all the spots in the lake, right? So this is population standard deviation sigma. Okay. So you need to be able to read the questions and identify all the numbers provided in terms of statistics or parameters and using appropriate labels to label them. That will help us to go through the process. Okay. So we need to do a hypothesis test. And if sigma is a given number, that will determine we need to do a z-test. Okay. If sigma is a given, then it will be a z-test. If sigma is not given, it should be a t-test. Okay. For any hypothesis test, we have to go through the 5-step procedure. So first step will be stating the hypothesis. Stating the hypothesis basically stating your research goal. So what are you trying to find out in the research? That will be your hypothesis. Second step is stating rejection rule. Basically, all you need to define is type 1 error rate. What kind of type 1 error rate do you want to allow in your study? If it's not given, we're going to use 0.05 by default. Okay. Step 3 will be calculating test statistic and find p-value. So test statistic is a statistic calculated by assuming the null hypothesis is true. Okay. And once the statistic is calculated, then the p-value will be the probability that you can observe a sample as extreme or more extreme than the sample you collected. So that will be a probability coming from different kind of distributions. In z-test, it will come from z-distribution, so you can look it up from z-table for the p-value. Once you find the p-value, then we need to compare p-value and type 1 error rate alpha. If p is smaller than alpha, you reject the null. If p is greater than alpha, we fail to reject the null, and either way we make a decision. That's step 4. And step 5 will be basically you need to tell a story about what you're finding to someone who doesn't know statistics. So that's the conclusion. Conclusion is not supposed to have any statistical term so that everyone can be able to read it and understand it. So that's our 5-step procedure. So keep that in mind. Now let's go through this. So we decided to do a z-test. So what's our hypothesis? When we state hypothesis, we have 2 hypotheses we have to state. One is null hypothesis HO. The other is alternative hypothesis HA. And the hypothesis, the null hypothesis stating something being the same, alternative hypothesis stating something being different. Okay. So now let's look at what's the research goal. Okay. Our research goal is trying to see if the average lead content in the lake is higher than 115, right? So something is higher than 115. Then what is that something? That's average of the population, right? We want to see the population average is greater than 115. Population average will translate into population mean mu, right? So this will be our claim. That will be our research goal. That will be our hypothesis. Okay? Since this claim is stating something being different, because this is greater than sign, right? So there will be our alternative hypothesis, because alternative hypothesis is a hypothesis stating something being different. The null hypothesis stating something being the same. So here will be alternative hypothesis, mu greater than 15. Oh, sorry, this is not 115, 15. Okay, higher than 15 ppm. Right? So alternative hypothesis here. Once you find one of the hypotheses, the other hypothesis is automatic. So all you need to do is change the greater than sign back to equal sign. So what it means is alternative hypothesis is average lead content of the entire lake is higher than 15 ppm, and the null hypothesis is average lead content of the entire lake is equal to 15 ppm. Okay, so that's our step 2. Step 1, stating your hypothesis. Then step 2, state the rejection rule, is always the same sentence. If p-value is smaller than a number, then reject the null. And this number is the only thing you could change in different hypothesis tests. And by default, we use 0.05, unless you're otherwise instructed. Okay, so that's step 2. Step 3, calculating test statistic and find p-value. So in z-test, the test statistic will be a z-statistic. Okay, so z-statistic will be x bar minus mu divided by sigma over square root of n. Then we need to check if we have all the values provided. We need all 4 items in order to calculate. So what is x bar? From the previous, when we look at those numbers, x bar will be 18.4. Mu, what is mu? When we calculate the test statistic, we need to assume the null hypothesis is true. So we need to assume this is true. That means mu equal to 15. Okay. Then sigma is given as 6.0. N equal to sample size. Here we have 10. So then we have everything we need for the calculation. We have 18.4 minus 15 divided by 6.0 over square root of 10. Okay, so we can calculate this test statistic using calculator. 18.4 minus 15, the result divided by 6 over square root of 10. So if we do the math, we got 1.79. So the test statistic is calculated. Now we can find the p-value. P-value is the probability that you assume the null hypothesis is true and you observe the value as extreme or more extreme than your sample data. So as extreme or more extreme, in terms of more extreme, it depends on your alternative hypothesis. If your alternative hypothesis is greater than sign, p-value will be a probability of z greater than calculated z. Okay? If alternative hypothesis take a different form, then your p-value will have to change accordingly. So refer to the canvas for that. So then we can see calculated z is 1.79. We can just replace it in there. Probability of z greater than 1.79. then this is some normal event that we can look up from Z table, right? So with a greater than sign, we can say that will be 1 minus probability of Z smaller than 1.79, right? So we can look up the Z table. With 1.79, if we look up on the Z table, 1.7 is here, 0.09 is here, so we got 0.9633. Okay, so there'll be 0.9633. And if you do the math, 1 subtract 0.9633, that's 0.0367. So we can use calculator to calculate that. So we calculate the test statistic Z, and we find the p-value from Z table. So step 3 is done. Then we go to step 4. So now we already find p-value from step 3, and we define our alpha in step 2. So all we need is determine what sign will go between p and alpha. P is 0.0367. It's definitely going to be smaller than 0.05, right? Since p is smaller than 0.05, we go by the rejection rule. Our decision will be, we need to reject the null. Okay, so step 4 is done. Our decision will be rejecting the null. What does it mean when we say reject the null? That means we have enough evidence the alternative is true. So we need to conclude it alternative is true, but without using any statistical term. So here the conclusion we can write. We have enough evidence that the average lead content for the entire lake is higher than 15 ppm. Okay. It would be nice if you indicate the significance level, but not required. So based on 0.05 significance level. So our conclusion will be, hey, the lead content in the lake is higher than 15 ppm. So when you make a conclusion, when you make a decision in inferences, you're not going to be guaranteed 100% correct. You have a chance to make an error. You could either make a type 1 error or type 2 error. So in this case, since you reject the null, then we have a chance to make a type 1 error. Right? So we have a chance to make a type 1 error. Doesn't mean we made a type 1 error. What's the chance to make a type 1 error? That's the type 1 error rate, alpha. So we have 5% of chance to make a type 1 error. In other words, we have 95% of chance to make a correct decision based on the analysis you did. So based on the probability, we're able to make a better decision, and that will help us to, for making any kind of good decisions using statistics. So this is how we do a hypothesis test. There are a lot of information involved: sample and population, identify all the parameters and statistics provided, and be able to make a judgment to see which hypothesis test procedure is appropriate. Here we only introduce 2 different tests, Z and T, but there are a lot more tests that can be used for different scenarios. Okay? And very important, hypothesis tests always have the 5-step procedure. Okay, so this is it. Thank you.